So in today's lecture, we are going to see two more operations, which again fall under morphological operations. And as we discussed yesterday, these operations are being performed on binary images. So let us proceed. So this is the agenda for the today's class. We will first quickly see what we discussed in the last class with respect to morphological operations, particularly dilation and erosion, and then we will cover these two new operations, opening and closing, and then we'll also see all these operations that we have discussed in the last class are opening and closing. Normally these are performed on binary images, but these operations can be also extended to be performed on the grayscale images. So we'll see how these operations can be actually performed on grayscale images. Okay. So very quickly, let's just first discuss what we discussed in the last class with respect to the operations or the applications where we have binary images and what kind of operations we do there. So one of the applications that we discussed in the last class was the connected component computation on the binary images. So this is basically demarcating the number of multiple number of objects or the number of regions that are there in the binary image. Now this may be required. This kind of computation may be required when we are trying to count the number of objects present in the image, number of foreground objects present in the image, or maybe we like to calculate some features like boundary of these objects or the area of these objects. So in those scenarios, we see that we need to first compute the connected component present in the binary image. Now, when we are computing the connected component, we discussed in the last class that we face some challenges, and these challenges come because of the existence of holes in the binary image and because of the existence of small fragments in the binary image, which may not be which may not be representing the true objects there. Okay, and we also discussed that solution to these problems, can come from the morphological operations. So we discussed that morphological operations actually can be used to clean up the images or the results which are available in terms of binary images. And in this cleaning process, we will be able to remove noisy pixels or small fragments present in the image, or using these operations, we can also fill the holes present in these images, in the foreground objects. Okay? And these were the four morphological operations that we listed: dilation, erosion, opening, and closing. Dilation and erosion we have discussed in the last class, and opening and closing we will be discussing in detail today. Let us first quickly have the recap of what we discussed with respect to dilation in the last class, and with respect to erosion, and then we'll go to opening and closing. So in the dilation, we discussed that this process actually, when we perform the dilation on any binary image, this grows features. That means it actually grows the size of the foreground object present in the image. Since the size of the foreground pixel grows, we include new and new background pixels to come and join the foreground object. In that process, we see that this fills the holes, right? As you see in this example here, when the dilation has been performed on this image, let's say in this particular object, all the pixels, all the holes have been filled here. And this filling has been achieved because when the object has expanded, the background pixels have got converted to foreground pixels, and in that process, the holes got filled. Okay? In the case of erosion, we see that when this operation is performed on the binary images, this shrinks the features. Whenever we are saying feature, this basically means the pixels which are representing the foreground object. Right? So in the last class, in the last slide also we mentioned features. These features are nothing but the pixels which are representing the foreground object. Okay? In these examples that we are having in these slides, the foreground object is represented by using the white pixels, but sometimes it may be, and here the background is black pixel, but sometimes we may find that the black pixels are representing the foreground object, and the background is represented using the white pixels, right? So that can change. In these examples, our foreground objects are represented using white pixels, and the background background is actually represented using the black pixels. So in the process of erosion, what exactly we achieve? We actually see that when we erode any image or when we perform erosion on any image, it shrinks features. This basically means that it reduces the foreground pixels. That means the size of the foreground object reduces. So when we reduce, we see that if the object is big, and this process is actually kind of iterative process. So we perform erosion once, and then again we perform erosion, and I mean this is done in few cycles. So we see that when we perform erosion a few times, if the objects are small, they may actually disappear after a few cycles of erosion. But if the objects are bigger, they will actually survive this process of erosion. So because we assume that our bridges, that means the white pixels which are connecting the two foreground objects, or the branches, this is again which is the pixels which are connecting the two foreground objects, or the noisy pixels like small fragments which are present in the image. Since all these kind of pixels which are representing bridges or branches or noise, they are going to be small in size. So because of this erosion, we'll see that they will, because of, we'll see that in few round of erosion, these small fragments will disappear, and only what will survive will be the objects which are bigger in size. Right? So that's what exactly we see in this output. When we are performing erosion on this, we see that we get this output where most of the small components that we see in this input image, like here, or these small components here or here, they have got disappeared, and we have got a clean image. There are few components which are not representing the true foreground objects, like for example this part or this part, but they have not got removed, and this is just because whatever number of erosion steps we have performed here, that were not sufficient to erode the small objects. So that is why they are still surviving. So when we are performing the erosion, it depends how many times we have performed the erosion, what kind of structuring element we have used to perform the erosion, and our output will be actually dependent on all that. We also see that, if you may be thinking that we can keep performing the erosion and until we lose these objects, these small noisy objects. But then we also see that because of the erosion, our size of the object is also getting reduced. Right? So we have to find out some optimum number of iterations which we need to perform so that we don't lose the vital information from the objects, and at the same time we are also able to remove the noisy pixels, or noise up to the maximum extent. Okay, so now let us discuss a few issues that are actually there that we see when we perform dilation and erosion, and then we'll see actually to overcome these issues only we have two new operations which are called opening and closing. So if you observe these outputs, the output of the dilation or the output of the erosion, in case of dilation we see that whatever size we are getting in the output, the size of the object is not same as what we had initially. For example, if you see what was the size of this face and what is the size now here for this face, we see that the size has grown. Okay, so when we perform actually the dilation, we see that it increases the size of the foreground object. Similarly, when we perform the erosion, then it actually reduces the size of the foreground object. You can see that here. So when we, let's say, performing the erosion on this object, the size of this object has gone actually down if you compare with respect to the output. Okay, so in case of dilation, we are increasing the size of the foreground object. In case of erosion, the process is decreasing the size of the foreground object. So in summary, we can say that when we are performing these operations, we are not able to maintain the original size of the objects. Okay, so we can say that that's kind of problem, because after removing the noisy pixels, we want our original object. We don't want our objects to be shrinked, or we don't want our objects to be increased in size. Okay, so to overcome these problems, we have the process of opening and closing. So we'll see that in opening and closing, these operations are also in some sense performing kind of dilation and erosion, but in those operations we will be able to maintain the original size up to quite extent. Okay? So how this can be done? So you can assume that is opening is comparable with erosion, and similarly the closing is comparable with the dilation. So in case of opening, we are performing erosion, but we are not just performing erosion. After erosion, we are performing the dilation. So opening is actually the process where erosion is performed first, and then the objects are dilated. Okay, so the dilation process is performed. So now you can just, if you just analyze this line, you can visualize that in the process, if this was your object, then in the process of erosion, let's say it has got shrinked. So now if you again perform the dilation, you will again get back your original size. But when you have performed the erosion and you have gone from this step to this step, this object was big, so it is present in the output. But if there was any small object present in the input, because of the erosion, that small object will disappear from the output. So if this was your input image and this was your output image, in the output image only you will see the bigger objects. Small objects will disappear. Okay, because of this process of erosion. So now, if you again perform the dilation and increase the size of the objects that are present here, you will be actually increasing the size of the objects which are the true objects, because when we have gone from here to here, we have removed all the noisy pixels. Right? So because of performing the dilation after erosion in the opening operations, we are able to maintain the original size of the objects up to quite extent. Okay, so when we are performing the opening, it is same as performing the erosion. Means this operation will be used to remove the noisy pixels or noisy objects from the image. But at the same time, our objective here is to maintain the size of the true foreground object. So when we are performing the opening, it will keep the general shape of the object, and it will perform smoothing with respect to the object. Okay, so that means with respect to foreground pixel, it will be performing a smoothing. That means it will be removing those noisy pixels, but at the same time, it will be able to maintain the general shape of the objects. Okay, so similarly, this as I just said, that closing is you can say comparable with the dilation. That means closing will be used to fill the hole. But as we discussed the problem in case of opening, in case of closing, we are performing dilation to fill the holes. But after dilation, we are again performing the erosion so that we can come back again to the we can bring back our true objects to the original size. Okay? So in this case, you'll see that again we will be able to keep the general shape of the object intact, and at the same time here we can say that we are performing a smoothing with respect to the background. Okay, we can see we can understand this process with this example. So in case of opening, as I just said, we are first doing the erosion, and then we are performing the dilation. So we are eroding the object first, and then we are dilating the object. So because of this, we remove the small objects, as I just stated in the previous slide, and we are able to keep the original shape of the objects present there. So here we see when we are performing opening on this, in this input image, there are circles which are of our interest, and there are some lines which are not of our interest. We want to remove them. So when we perform a few cycles of erosion on this object, we see that these all lines actually get disappear. Now, when we get that intermediate image, and then when we perform the dilation on that image, we see that we again get back the circles or these white dots in their original shape. Okay. So when we are moving from this to this, before opening and after opening, we see that in the input image we had noisy pixels present, but in the output image, all the noisy pixels have been removed. And at the same time, we are able to maintain the original shapes of all these objects. Okay. So mathematically, we can say that erosion can be defined using this equation. We are performing B is a structuring element. With the help of B, we are performing opening operation on A. And since, as we discussed, that opening is nothing but erosion followed by dilation. So first A is eroded by B, and then whatever output we are getting from here, that is being dilated with the help of B again. So we are performing erosion followed by dilation here. And because of this, as we saw in the examples, we are able to eliminate all the protrusions that we have in the image. This breaks the necks, the bridges that we have in the binary image, and also it smoothen out the contours that are there in the image. Okay, so more precisely, we can understand that with the help of this example. So in case of opening, let's say in this image we are performing our original object was the square that was painted completely blue, dark blue, and we are, let's say, performing the erosion with the help of we are performing this opening operation with the help of this disc-like structuring element. So when you can imagine that if you would have performed the erosion of this object by this disk, if you remember, we said that we are going to, when we are performing erosion, we only include those coordinates or the pixels in the output where are those pixels are the coordinates of the two objects in the output, where if we place this structuring element, the structuring element is completely inside the object. So in that sense, we can say that if you just see the trajectory of this disk, you'll see that it will move something like this. It will move like this. Okay. So that means if you erode it, only in the erosion you are only going to get this area. Now, now since after erosion we have dilated it. So once you perform the dilation on this, you will see that this will in the process of dilation, if you remember, we discussed that the structuring element can be considered as the stamp, and this need to be put at all possible pixels in the foreground object, and whatever when we are putting the structuring element at a particular place in the on the foreground object, whatever pixels are foreground or background that falls under that structuring element, they are included in the output. So after erosion, our object is only restricted in this rectangle, this shaded rectangle. So to dilate this, we have to place this structuring element at all possible places in this shaded area. So when we are putting this structuring element on this shaded area, we see that the extreme places where this can be put is this boundary, right? So when we are putting this on the boundary, we see that this creates this kind of shape, right? And all other points that we are seeing here inside, they all will be actually generated when this disk is placed at any point which is inside this boundary that we got at the time of erosion. Okay, so because of that, we'll see that all these corners have been actually got smoothed out, right? So this was a sharp corner here, but you have a smooth corner here because your structuring element is at this. Similarly, you have also a smooth corner here, you have a smooth corner here, and so on. Okay. So one thing you can notice from this example that when we are performing the opening, that means when we are performing erosion followed by dilation, we are not able to completely retain the original object. We will be able to retain the shape up to quite extent, but I mean, it may not be exactly same as what we had at the beginning. That you can actually observe here. So initially our object was this big rectangle where this everything was dark blue, but when in the output you don't have that I mean the area, this light blue area, same as the previous area which was the dark blue. That means we have actually in the output we will not have these corners. Right? So whatever you are getting as output, this light blue area, that is very close to what we had initially, but it is not exactly same as what we had at the beginning. Okay, when we started performing opening operation. Okay. Now let us discuss the closing. So in case of closing, we are going to perform dilation first, and then we are going to erode so that we can come back to the original. We can bring back the objects to their original shapes. So in this process, we'll see that we will be able to fill the holes, and we will be able to keep the original shape. The idea, the reason here for this is that because holes will be small, so when we are performing the dilation, small holes will get filled. Only the bigger object will survive. So when we are performing the, erosion after the dilation, we will be actually eroding the bigger objects because small holes have already been filled, so they are not there. So this erosion is only performed on the two objects. So that's what you see here. When the dilation is performed on this image, small circles have got filled. These bigger circles, they have also got shrinked, but because those small circles are very small, because of the dilation, they will completely disappear. These bigger circles will be only get their size reduced. So when we after performing the dilation, when we perform again the erosion, we'll see that whatever size that has got increased for these objects, that will be again eroded, and then up to quite extent we will get back the original shape of these objects. Okay. Formally we can define, and please remember for opening we normally use this symbol, and for closing we use this symbol, that means this solid dot. And as we said that closing is nothing but dilation followed by erosion. So if let's say the A object is we are performing closing on object A or on image A by using a structuring element B. So with the help of B, first A will be dilated, and then whatever output we are getting on that, we will again use the structuring element B to erode it. Because of this, again it will smooth out the contours. It will fuse the narrow breaks and long thin curves that we have in the image, and it will also be able to eliminate the holes. It will also fill the gaps that are present in the binary image. Okay. We can see both these operations performed on this image here. So let's say image A is the input image where we want to perform opening and closing. When we are performing opening, we will be first doing the erosion, and then we will do the dilation. So when we are doing erosion on this image, we'll see that this small structure that we have here, since this is small in size, it will get eroded. So after erosion, when we perform the dilation, we will get this image as our output, because in the process of erosion, this structure has been removed. So when we are doing the dilation, this will again not get developed. Only what will get developed, or what will be taken back to the original shape will be only the objects, which are the two objects. Okay. Similarly, when we are performing the closing on A, let's say we are performing the closing on A. So when we are performing the closing, this is dilation followed by erosion. So when we perform the dilation, this small hole gets filled, and also other objects, that means this object in this boundary and the boundary of this object, this will also get expanded. So again, to get back these objects to their original shape, we'll perform the erosion. So when we are coming from here to here, in the first part where we dilated, this hole got filled. So when we followed the output by erosion, we don't see the hole here, because hole has already been filled in the first part of this closing operation. Okay, so this is the output we are going to get when we are performing closing on A. And this is expected, this is the output that we are expecting when we are performing opening on set A. Okay. So in summary, we can say that erosion shrinks the objects, dilation grows the objects, and when we are combining these two, when we are combining erosion and dilation in a certain order, we are able to keep the general shape of the object, and we are able to also remove the noisy pixels, we are able to also fill the holes present in the image. So when you are performing the opening, this basically keeps the general shape of the object, but it actually does a smoothing with respect to the objects. Similarly, when we are performing the closing, this again keeps the general shape of the objects present, foreground objects present in the image, but it performs a smoothing with respect to background. Okay. So till now we have discussed all these operations on binary images, but these operations can be extended to grayscale images. Let us see how we are going to do this. So as I just stated, dilation and erosion, this is typically performed on binary images. Here we are going to see how to perform these operations on grayscale images. So if you remember what we do in the dilation, if our foreground object is, let's say, represented as 1, so when we are dilating, the background pixels are actually being converted to 1, right? Or if you, let's say, consider 1 as white, then the background pixels which were black, they are actually getting converted to white pixels. Similarly, when we are doing erosion, we are actually converting our foreground pixels which were white to black. So in the process of dilation, black background pixels are being converted to white foreground pixels, and similarly in the case of erosion, white foreground pixels are being converted to black background pixels. When we are saying that when we are performing dilation in case of binary images, we actually make the values 1. For the background, we make them 1. Equivalently, we can say that so we have the two kind of intensities, 0 and 1. So in the process of dilation, 0 is converted to 1. So parallel to that, we can say here that when we are doing this with respect to the grayscale images, we can consider the maximum that we get below the structuring element. Okay. Similarly, when in the case of erosion, we are going from 1 to 0. 1 is the foreground pixel, 1 representing the foreground pixels and 0 representing the background. So in case of erosion, we are going from 1 to 0. So this can be actually replaced by a min operation when we are talking about grayscale images. Now please remember, when we are saying this can be replaced by max or min, we are assuming that our foreground objects are lighter in color and the background objects are darker in color. That is why in the erosion we are basically increasing in some sense you can say we are increasing the background. So when we are increasing the background, we are making the pixels black in the case of binary images, and since here the darker pixels are we are assuming that they are representing the background. So that is why by considering the min operation, we are basically choosing the min value or min intensity among the pixels which are falling below the structuring element. Okay. Similarly, the case here, since we are assuming the foreground is lighter in color, so by choosing the max value, we are actually choosing with the most light pixel falling below the structuring element. Okay. So when we are performing the morphological operations on the grayscale images, we are going to have same kind of structuring element, but now in place of choosing the value 1 or 0 respectively in case of dilation and erosion, we are going to choose the value max or min from the pixels which are falling below the structuring element. Okay, so you can see this kind of effect here. So when the this image is dilated, you see that more and more white pixels have got appeared here in the output. But when this is eroded, more and more black pixels are uh, added in the image, because erosion is actually increasing the background and dilation is increasing the foreground, right? So that kind of effect you can visualize from these two outputs. These are the available MATLAB commands. You can just try them for eroding the image. You can use IM erode. Similarly, for dilation, you can use IM dilate. For closing operation, you can use IM close, and for opening operation, you can use IM open. And you have to perform the two things, as I mean, we know from the definitions that we have seen. We need the image where the operation is to be performed and the structuring element. In MATLAB, by default, if you're not supplying the structuring element, it will assume the default structuring element. If you want to choose a different structuring element, you can just provide that. By default, it chooses this kind of structuring element. Okay. There are various applications where this morphological operations can be used. Some of them we have already discussed. For example, when we are doing the pre-processing of the image, that means we want to remove noise from the images, or we want to simplify the objects. There we can use these operations. So this simplification basically means that, let's say you have two objects and then there was some noisy connection that was present between them. So when you are performing these operations, this will get removed. So the object which became complicated because of this connection will get separated in two separate simplified objects. Okay. Similarly, for the thinning, we can use this. You know that in erosion, the objects are shrinked. So if let's say you have an object and you want to make a thin object out of that, you can perform erosion multiple times to thin it. Similarly, sometimes an object is given and then we want a skeleton, right? For example, we have a kind of let's say a structure like this. Okay, so and this is a thick structure. Let's say this is X shape, which is a thick structure, but we don't want this thick structure. We only want one line, simple structure in terms of the line. So you can perform the erosion on this and get the skeleton. You can just assume that this is the skeleton of this object, because this is giving you the basic shape of the object. In case of segmentation, these operations are used. We will be talking about segmentation in upcoming lectures. So there we'll see that there is a segmentation technique called watershed model, where the morphological operations are being used. To calculate the quantitative description of the object, for example, area or perimeter, as we discussed, these morphological operations can be used. Okay. So with this, we conclude the discussion on morphological operations.